Hi, good morning. So this is Reshma. Welcomes you to the session on database management system. And in today's session, so we are going to discuss with the concept of Cartesian product in relational algebra. So now here the Cartesian product is also referred as cross product. So now this is the basic operation which will be used to work with different join operations. To perform any join operation, first we need to apply cross product, then we can complete our join operation. So now we'll see how this cross product will work. So now here this cross product is denoted by the cross or into mark, and this is a binary operation, means it will be applied on two relations. We can find Cartesian product of relation R with relation S. And to apply Cartesian product on two relations, that the relations need not be union compatible, or they need not be type compatible. So the meaning of type compatible we have discussed while taking set operations. As we know, in set operations, the relations should be type compatible, but here they need not be type compatible. Means the two relations need not to have same degree, and they need not to have same domain for the attributes. If they have one, they can have all attributes from one table may be different from other tables. For example, I can perform cross product on student table with the employee table, where there is no relationship between student table and employee table. I can perform join operation with student with company department table of any company. So that is here there is, without having any relationship between attributes of one table with the another table, we can apply this cross product operation. So the relations need not to be in type compatible. So now we'll see what are the different notations. So now here if I have relation R, relation S, the cross product can be represented as relation R cross product relation S, where R contains the attributes A1 to AN and S contains the attributes B1 to BM. So now here, after performing Cartesian product on R and S, we may get the relation Q, and the number of tuples in the relation Q will be equal to sum of the attributes from first relation and the second relation. So the relation Q will have n plus m attributes, n attributes of the first relation plus m attributes from second relation. So number of columns will be sum of the columns from both the relations. So it will be like this. We'll get a new relation Q which contains attributes from all attributes of the left relation followed by all attributes of right relation. And if you talk about the tuples in the result, so if the relation R has nr tuples and relation S has n is tuples, number of tuples in relation R is nr, number of tuples in relation S is ns, then total number of relations in the Cartesian product of R and S, it will be equal to nr into ns. So that is the product of number of tuples in left relation and number of tuples in right relation. So we'll give the total number of tuples in the result of Cartesian product. So number of columns will be sum of the columns, number of tuples will be product of the tuples. Okay. In the result of Cartesian product, total number of columns will be equal to sum of the columns from two relations. Number of tuples will be equal to product of tuples from the two relations. So see, for example, here I have table 1 and table 2. The two relations, table 1 and table 2. So now table 1 has 3 tuples, table 2 has again 3 tuples, and number of columns also 3 and 3. So now Cartesian product will be written as table 1 cross table 2, and the result we have stored in table 3. So now the result will contain 6 columns. First 3 columns from left relation, that is from table 1. Next 3 columns from table 2. So these are the number of columns, and number of tuples will be equal to product of these. So how it will perform product here? Take the first tuple from left relation, multiply that with all tuples in the second relation. So AX 999 will be multiplied with 1D 999, 2E 968, 3F 453. So 3 times A will be multiplied with all values of all tuples of table 2. Similarly, now go to second tuple in the table 1, that is BY 968765431, and this tuple will be multiplied with each tuple of second relation. So 3 tuples we have in second relation. So second tuple of first relation will be written 3 times. Similarly, now I will go to CZ453. CZ453 will be multiplied once with 1D 999, next with 2E968, then with 3F453. CZ453 with 1, then C with 2, C with 3. So that is here each tuple of left relation multiplied with all tuples of second relation. So here we will get total number of tuples will be the product of tuples from left and right relation. So product is here 3 into 3. So now here we got 9 tuples. So like this Cartesian product will work. So now assume that I want to display names of each female dependent. So then what we can do here, we need to decide which tables to be considered. Here I need employee table where we'll get the owner, and in dependent table I will get the dependents. So now we will apply Cartesian product on this. So what I have done here, we have selected female employees from employee table using select operation. Select x equal to f, it, from employee it will select only female employees. So that we have stored in intermediate results female underscore emps. Now female underscore emps includes only female employees. So now we will take, this is the list of female employees. We have 3 female employees from the employee table. So then we'll apply. So what we have done here, only first, because here I want to display only names, we have taken f name, l name, ssn, that I have stored in emp names. Okay, these 3 columns. So now we'll apply cross product on emp names with dependent. So now, so this is emp names which we have derived, extracted. This is the original table of dependent. So now here we can directly apply the Cartesian product to get all the female dependents. So because EMP names contain only female employees, multiplying this with dependent table will give us the solution. So how it will apply? So as we have discussed, each tuple of left table will be multiplied with all tuples of right table. It first will start with first tuple of EMP names, that is Alicia. Multiply Alicia with 333, so that is all 1, 2, 3, 4, 5, 6, 7, all 7 tuples of dependent, like this. First tuple of left with all tuples of this. So then I will get total 7 tuples. The next Jennifer tuple will be multiplied with all tuples of dependent. Again we will take Joyce. See, Joyce will be multiplied with first tuple of dependent, then with the second tuple, third tuple, fourth with, like this up to last tuple 1, 2, 3, 4, 5, 6, 7, 8, 9. So here, as the diagram indicates here, each tuple from left relation multiplied with all tuples of the right relation. So then it will display product of these two tuples as the answer. So left tuple, left relation 3 tuples, right relation 1, 2, 3, 4, 5, 6, 7 relation 7 tuples. So 3 into 7 total 27 tuples will be displayed in the solution. And number of columns will be 3 plus 5, 8. So here we get 8 columns. First three columns are from left relation. Next columns are from right relation. And number of tuples will be 21. With Alicia, 7 tuples. With Jennifer, 7 tuples. With Joyce, 7 tuples. So total 21. So 3 into 7, 21 tuples will be displayed in the result of Cartesian product. So this is about the Cartesian product. So then from this, just compare SSN and ESSN to get who are depending, because here among these 21 tuples, all tuples may not give the required answer. It might generate some additional tuples. It will generate the tuples which are not available in the original relation, which may not be matching with the valid required solution. So to get the exact required solution, later we will apply additional conditions and we will perform join operation. So now here from this product, we will match SSN with ESSN, that is we will be finding which employee, which dependent is depending on some employee. For example, here 333, that is dependent name Alicia. So Alicia is depending on 333. Then let's see here, female dependents. We have three: Jennifer, Joyce, and Alicia. Then we'll get only Jennifer, only on Jennifer. He is having the dependent. Then so finally we have displayed the complete name. Dependent name is Abner. Abner is depending on Jennifer. So because Jennifer's, yes, we have match here. Whether these two are same? No, no, no. Where we'll be getting SSN equal to SSN only in this column. So where I have marked with pink color, SSN of Jennifer Wallace is same as SSN of Abner. It indicates Abner depending on the female Jennifer. Okay, so like this, our cross product will work. But result of cross product contains additional tuples also. With no condition, it is just multiplying. Then according to the requirement, we can take the help of the cross product results and we can move further. So this is about the Cartesian product. And thank you for watching the video. In my next session, I'll continue with join operations. To get the notification on those videos, please subscribe and click on the bell button. Thank you.